I'm starting to teach here, so sorry I should have waited around. First thing from a couple days ago. You guys already know what's that going to be without even plugging anything in your calculator. That's going to be a graph of a what? A circle, right? X-axis going out to 5. Here's what I'm going to do with you today. We're going to add something or subtract something onto it. If the numbers match, it's one type of graph. All right. If the numbers match it, and I'll tell you the type of graph it is when we graph it. If the numbers don't match, it's going to look totally different. Okay. Those two graphs right there are totally different. All right. So if the numbers match, it's one type. If they don't, it's another type. And we're going over both right now. All right. Ready to go? I'm not going to show you anything. Thursday is totally different. So it'd be great if everyone could be here Thursday. Totally different type graph, totally different approach. Today, though, same thing you did with the circles. Can you type into your and I'm sorry, I'm not trying to be funny here. Can you type into the calculator and can you plot points? That's all it is to it. All right, that's all this is to it. Here we go. 5 minus 5 sine theta. Notice my numbers match. I'll tell you what type of graph it is after you see it. All right. Again, we'll hold hands here first for the first couple. 5 minus 5 sine 0. Make sure you're in radian mode. 5 minus 5 sine 0. And you get an R value of 5. So you're going to graph 0, 5. I'm sorry, 5, 0. It's just a matter of do you know how to graph it or not? And what day is this on your paper? 17? Yeah. 17. We don't know how to graph that yet. Okay? So at 0, I go out to 5. 1, 2, 3, 4, 5. All right, let's keep trucking along. Pi over 6, plug it in. Round to the nearest 10. Yeah, Lizzie.
For the middle graph, do we always have to write 5 or R equals? We just write the answer.
I don't care. I don't. 2.5? How's 2.5? If no, let me know, please. 2.5?
Yeah.
All right, so go to pi over 6 and go about 2.5 circles out. Pi over 3, we're getting a little smaller here, so have to be careful. Five minus 5 sine pi over 3. What do you got? Point 7. All right, be careful. You're not going a full circle. Just be below it. So at pi over 3, don't go anywhere past the first circle. I know it's tiny, but that's where it's going to be. Please, please, please keep track of your points because this is how the order you're going to have to connect them. Keep track. We're going to have a ton here in a minute by the time we're done with this whole graph. All right, pi over 2.
Yeah.
Yep, that's a nice one, right? Where am I? Where's that point? 0 pi over 2. Where do I plot that? Right in the center. There it is. Two pi over 3. Keep trucking. 0.7 again. Hey, is that negative 0.7? No. So none of us should be going on the other side. We are right on 2 pi over 3. I have not gotten a negative R value yet. 0.7 right there. 5 pi over 6. Still positive. 2.5, still getting these values. We all good? So 5 pi over 6, 2.5. Again, please keep in mind what order you plotted these all, or connect them as you go, whatever. And then look at Desmos and say, oh, I got to make sure this looks more like this graph on the Chromebook than what mine looks like. What do you got for pi? Head back out to 5. I'm getting 7.5. 7 pi over 6. Ooh, way out. Then you guys should have the big dog here, huh? For 3 pi over 2. How far are we at? How far are we going here? 3 pi over 2. 10 out. I think I gave you exactly 10 circles. So 10 out at 3 pi over 2. Let's finish this off. 5 pi over 3. 9.3 out.
The hard. What? I might be messed up. Wait, that's not a hard. Makes it a little lopsided. Not a hard.
And again, this is why you use Desmos, so I can actually see what this should look like here. So if I try to connect the dots,
Oh, you chose red.
that pains me.
It's so wonky.
When the numbers match, you are going to get one that looks like this, and it's called a cardioid. Cardioid graph. Cardiovascular,
I get it.
leading to your heart,
Oh.
if it exists.
Very dark.
Also, what showed up in that equation, sine or cosine?
Sine.
Oh, shocker. What axis was your heart on? The y-axis. And it was -5. Shocker. It was on the bottom of the y-axis. Okay? Questions? Cardioid graphs, when those numbers match. All right, what happens if they don't match? You don't get a cardioid. You get something else. So this one's a little bit more involved. Definitely got to keep track of your points here. So now I got a 1 and a 4 there, but it is cosine, so guess which axis I'll probably be on? What do you think? The right or the left side? Good call. Right side of the x-axis. All right, let's see what this looks like. Plug in 0. There's still one on my desk over there if you need that one. That's a little more updated one on the brown desk over there. What do you got when you plugged in 0? 1 plus 4 cosine 0. 5. Yep, should have got 5 there. So 5, 0. Same way our last one started. I'm just forewarning everyone, keep track of the order. Pi over 6. 4.5. Keep trucking. 5 pi over 3. 3. Top of the grid. Pi over 2. Should have 1. 1 pi over 2. All right, now we got to make sure we're good on the graphs here. First time today. What's your R value for 2 pi over 3? -1, yeah. So what do we got to be? You should not be graphing at 2 pi over 3 now. R value is negative. Don't graph at 2 pi over 3. Where should we graph? We should be graphing at 5 pi over 3. 5 pi over 3. 1 away from 5 pi over 3 here. Directly opposite 2 pi over 3 is 5 pi over 3.
Oh my god, I hate these lines. Me too.
Use it. Grab a straight edge. No one's stopping you from grabbing a straight edge.
Yeah, I got
That's the opposite.
no, but like it's like switch your eyes a little bit.
Here's the other Ava. Here, in all seriousness, I have the same issue. You want to go? You want to get into my go around?
Yeah.
Watch. It was 2 pi over 3, right? Which is 2 away from here. So I got to go 2 away from here. Okay.
Yeah,
I'm the same way with the lines.
My eyes are like killing me.
5 pi over 6, -2.5. All right, so don't go to 5 pi over 6. Where are we going now? 11 pi over 6.
Five pi over 6. What'd you get? But it's -2. I think.
What kind of sheep is this?
Yeah, keep track of your points here because it's about to get a little nuts. Pi. At pi, you get -3. That's your call. But just make sure you check it at the end so you know exactly what it should look like in case you got to erase it. Hey, negative. Now we got 2 points on the same angle.
Yeah.
Because now it's pi, but I got to go opposite at 0. 1, 2, 3. So make sure you know, again, order we're connecting them here.
Spiral.
All right? And we still have 3 more points to go.
I think it's a shell.
7 pi over 6, -2.5. So nobody graph at 7 pi over 6. You should be at where?
Opposite.
Pi over 6, right? So at pi over 6, everyone should be going 2.5. Oh boy. A lot of points on there.
No, it's just a spiral. It's kind of cute.
And then why don't we just get nuts here? What do you got at 3 pi over 2? 3 pi over 2? Yeah, 1. The positive 1. So on 3 pi over 2, go down 1. Oh boy. A lot of points here. Make sure you know the order you graph them, huh? Tried warning you.
Them while you go?
Yes. But like I said, check it on Desmo so you know the actual shape when you're done. Okay? Because, yours, you might be here, but it's just supposed to be nice and smooth instead. That's probably a bad example. All right, let's finish it. 5 pi over 3. R equals 3.
Wait, what?
We go out to 3. 1, 2, 3. All right, we ready for this bad boy? Where you started and where you went and finished.
That looks kind of weird. Oh, it's a heart.
How is that a heart?
Are you sure that's a heart?
That's a leaf.
That's a heart. Actually.
Where do you see a heart?
I should connect it as I want.
I think it's an interesting heart.
I think I messed it.
Have you never drawn a heart like this?
And then here we go. Let's just finish this up so you can do your own thing here. The official name to this, when the numbers don't match. When they do match, remember it's called a cardioid, the heart. When they don't match, you can impress people later with your vocabulary. It's called a limasan. A limasan when they don't match. Right. So cardioids and limasans today. Thursday it'll be petals.
No, we are.
I like this though. This is
All right, we're good. Thank you.
I know.
Can you give it a